Welcome to EDU World Space.
Okay, so we're doing chapter 34, problem 77 here. So part A says you want to use a lens with focal length of 35 centimeters to produce a real image of an object. So real. And we want the height of the object, height of the image twice the height of the object. So image height equals 2 times object height. Cool. So what kind of lens do you need? And where should the object be placed? Okay, so we already know if the image wants to be real, diverging lenses always produce virtual images, so converging lens, automatically we know that. So now let's try and figure out where these will be placed. So it's kind of tricky because we don't really have S or S prime, and that's usually how we solve these problems. But let's do some tricks here. So we know the magnification needs to be negative S prime over S, which is also Y prime over Y. Okay, so from this, we already know that S prime is greater than 0 because the image is real. S also must be greater than 0, and we know that Y is greater than 0. Now, the only way that we can satisfy all these conditions and this equation, you should see, because there's a minus sign here, if all three of these are always positive, the only way is if y prime is negative. So we know that the magnitude of y prime is equal to 2 times y, and then we know it's negative, so now we know that y prime has to be negative 2y. Okay, so from this we can now plug in, and we know that this is negative 2y over y, or magnification equals negative 2, and this equals negative s prime over s. So if we multiply this out, we should see that s prime equals 2s. So these are both positive. We already solved that out. Let me write this today. So now we got to go to the thin lens equation. So we can plug in 2s and replace for s prime, and we have 1 over s plus 1 over 2s equals 1 over f. If we rearrange this and solve for s, we can see that it's just 3f over 2, or 3 halves times 35, and that's 52.5 centimeters. So all we have to do is put the object 52.5 centimeters to the left of the converging lens, and we'll get it where we want it. Awesome. So part B now. Part B says we want a virtual image of the object with the same magnification. So now, if the image is virtual, we know that S prime must be less than 0. Going back to our magnification equation up here, this then also will apply or imply that S and Y are both greater than 0. And the only way this can happen is if Y prime is greater than 0. So in this case, we know that Y prime is 2Y now instead of negative 2y, so the image is going to be upright. We then can plug this back into the equation like we did before and get the relation between s prime and s, and that it looks very similar, just have the minus sign now. So now this is our new relation, So if we plug that back into the thin lens equation, we should have 1 over minus 2s here equals 1 over f. Again, we just solve for what s is in this case, and we should see that 1 over 2s equals 1 over f. Now, s we already said is positive, so that means f is positive, which must be a converging lens, because diverging lenses have negative f's. So now we can just plug in what f is, because we know that it has to be positive, so 1 over 2s equals 1 over 35. Rearrange that, and s equals 17.5 centimeters. So if we want a virtual image with the same magnification, we also use a converging lens, but instead of placing it 52.5 centimeters to the left of the lens, we'll place it only 17.5 centimeters to the left. But in both cases, there are converging